Hello dear students, myself Mohammad Wasim, Assistant Professor in Mathematics, Arts Science Commerce College, Badnapur. Today, as we know that we have studying about inverse Laplace transform, in which we are studying about application of some theorems, and we have completed our application of some theorems like as linearity property theorem, first shifting and second shifting theorem, and scaling theorem. Now we have studied in previous lecture Heaviside expansion formula. Today we are going to study about convolution theorem. Convolution theorem in which we have two functions in multiplication. We will get integration from 0 to t f of u g t minus u du. It is formula to solve when two functions are in multiplication and they ask us to calculate if two functions are given which are in multiplication, then we can distribute inverse Laplace transform to each function directly. So if we want to find such or if we want to calculate inverse Laplace transform of such function which are in multiplication, we have two different methods. One is partial fraction method. By using partial fraction method, we make this function into addition or in subtraction, and we can distribute inverse Laplace transform to each expression of that function. And the another method is convolution theorem. Convolution theorem is somewhat difficult to solve because we need integration. We need basic integration, knowledge of basic integration in this convolution theorem, and many students are not comfortable with integration. So it is somewhat hard to solve the example. But if in exam they ask to find inverse Laplace transform of such function with convolution theorem, we can't apply partial fraction method to such type of example. We have to use convolution theorem for solving such type of example. So we are going to start, or we are going to solve some examples which are based on convolution theorem. It is somewhat difficult, but if we take some time to understand this method, we can easily solve such type of example. And in this theorem or in this method, we need knowledge of basic integration, so we can easily solve example. So start with the example. That is find the inverse Laplace transform of 1 upon s minus 1 root s by using convolution theorem. If we want to solve this by partial fraction, then it is very easy to solve, but they ask us to solve by using convolution theorem. Correct? Convolution theorem. Now we have f and g are in multiplication. We have to find f of u and gt of u. So consider f is equals to 1 upon s minus 1 and g is equals to 1 upon root s. Find f of u and g of u. So find the inverse Laplace transform of f is inverse Laplace transform of 1 upon s minus 1, and which will use us e raised to t. Correct? We have just find inverse Laplace transform of 1 upon s minus 1, and which is e raised to t. Since g is equals to 1 upon root s, and we know that Laplace transform of t raised to n, Laplace transform of t raised to n is equals to gamma of n plus 1 s raised to n plus 1. Similarly, if we have to calculate Laplace transform of t raised to minus 1 by 2, we will get gamma of minus 1 by 2 plus 1 and s raised to minus 1 by 2 plus 1, and it will use us gamma of 1 by 2 upon gamma of s gamma of 1 by 2 upon s raised to 1 by 2, and which is equals to, we know that gamma of 1 by 2 is equals to root pi, so we will get root pi and root s. And if we apply inverse Laplace transform on both sides, we will get 1 upon root t is equals to inverse Laplace transform of root pi upon root s, and it will be equals to root pi into root t inverse Laplace transform of 1 upon root s. So if we see g will be g of t will be 1 upon root pi root t. Now we have inverse Laplace transform of f into g is equals to integration from 0 to t f of u g of t minus u du. Now selecting from this e raised to t and g of t raised to t, or we can write it as integration from 0 to t f of t minus u g of u du. If this integral both are equal, as per our convenience we use either first one or either second one. So we have to choose a function having t minus u, a function having t minus u easiest function. If we choose a function which has variable t minus u easiest function, then we can easily find the integration of such function. So we have e raised to t and 1 upon root pi root t, in which in e raised to t and 1 upon root pi root t, the easiest function is e raised to t. So we will use this function and this integration from 0 to t e raised to t minus u, and g of u is 1 upon root pi root u du, and we can write it as integration 1 upon root pi integration from 0 to t e raised to t into e raised to minus u root u du, and it will give us e raised to t upon root pi integration from 0 to t e raised to minus u and root Now to solve this expression, put u is equals to x square. So we will get du is equals to 2x dx as u running from 0 to t, x will run from 0 to root t. Correct? Therefore, it becomes e raised to t upon root by 0 to root t e raised to minus x square upon x du will give us 2x dx, 2x dx, x will cancel. We will get 2 e raised to t root pi 0 to root t e raised to minus x square dx, and it is formula for error function. So we can write it as 2 into e raised to t root pi error function of x, and it is the required result for our example. In this example, what we have done? We have two functions which are in multiplication, and we have to calculate inverse Laplace transform of that function. We have choose one as f of s and another as g of s. Now we have find inverse Laplace transform of f of s and inverse Laplace transform of g of s, and by applying convolution theorem, we have two integral which are both equal. Integration from 0 to t f of u gt minus u du is equals to integration from 0 to t f of t minus u du du. Whenever we have f of t is simpler, we will use the second expression, and when we get g of t is similar, then we will use this first integral. After putting values in this integral, we can solve by using simple basic knowledge of integration. We can solve that example, and applying knowledge of integration, we can solve and get exact result. Now take one more example. One more example, and that is 1 upon find the inverse Laplace transform of 1 upon s plus a and s plus b. We have to calculate inverse Laplace transform of this function, and we can consider f of s is equals to 1 upon s plus a, and g of s is equals to 1 upon s plus b. By using inverse Laplace transform of f of s, we will get inverse Laplace transform of 1 upon s plus a, and it will give us e raised to minus a. Similarly, inverse Laplace transform of g of s will give us e raised to minus bt, and both are equal, so we can use first or second integral. Both are same for this function. Now f of u will give us e raised to minus au, and g of t minus u means we will get e raised to minus b t minus q. Correct? So integral becomes inverse Laplace transform of f into g becomes integration from 0 to t e raised to minus au into e raised to minus b t minus u dq. After simplifying this, we will get e raised to minus bt outside integration from 0 to t e raised to minus au minus minus plus become plus bu du. Correct? And it is e raised to minus bt integration from 0 to t e raised to minus taken outside, we will get a minus b u du. And when we apply integration, we will get e raised to minus bt e raised to minus a minus b u upon minus a minus b, and that is the limit of integration 0 to t. Now putting values of upper and lower limit of integration, we will get e raised to minus bt minus b minus a, multiplying minus inside, we will get e raised to b minus a t and b minus a equals 0. So we will get e raised to minus bt upon b minus a and e raised to minus b minus a t minus 1. And it is the required result for this example. In this example, we have to calculate inverse Laplace transform of 1 upon s plus a into s plus b. We have choose 1 upon s plus a as f of s and 1 upon s plus b as g of s. By finding inverse Laplace transform of first f of s and g of s, we will get e raised to minus at. Similarly, we will get e raised to minus bt. Both the functions or both the result are equal, but only coefficient of t is different. So we can choose f of u and g of u, any one of them, and we have to choose by using first formula. F of u becomes e raised to minus au and g of t minus u becomes e raised to minus b t minus u. We are replacing u by t minus u, or we are replacing t by t minus u, and putting this value in this integral and simplify to this integral, we will get e raised to minus bt and integration from 0 to t e raised to minus bracket a minus b u du. After applying formula for e raised to x, we will get this one, and by putting upper and lower limit of integration, we will get this, and it is the required result for this example. And today it is enough to understand convolution theorem. We will stop here and we will continue with more 2 or 3 examples, and we will finish this lesson after these 3 examples. Till then, thank you. Bye.